Hello and welcome back to the Fullerton College Print 101 class. This is Professor Ben Hewitt, and today we're going to talk about the topic that is nearest and dearest to my heart in printing, for this was my career for a decade before I started teaching. We are going to talk today about digital prepress. This also aligns with Chapter 7 in your textbook. You probably have some questions about my picture here, although this far into a semester, you're probably sure that yes, your instructor does have a thing for aircraft. But why? Why in particular would I be showing this picture? Also, bonus question for anybody who cares about these things, can you tell what kind of plane this is from the image seen here? Yes, one of the key identifying features of this plane is actually in the picture. Okay, moving on. We will come back to this picture when we get to that part of our talk. So prepress in general is talking about the steps that happen before you print something. In the old days and in the older days, even not in like the oldest of days, prepress was a physical thing that you did. Prepress was cutting film and gluing it. I know I've made the stripping joke already in layout, but there it is again, stripping slash paste up, where you cut and glue different pieces of film together to expose a plate. But that way of life is all but gone now and has been replaced by computer prepress or digital prepress. At this point, you don't really necessarily need to say the word digital in digital prepress. The digital is silent. It's just implied because almost nobody does analog prepress anymore. So digital prepress takes place on computers and using electronic computer controlled equipment. The basis of all that is a binary system. And I can't hear the word binary without thinking about a piece of music and also a scene from my favorite movie right here. This is not my favorite scene in the movie, but it's a scene from my favorite movie. When they talk about understanding the binary language of moisture vaporators, as well as the language of binary load lifters, being similar in this case. Also, Tatooine, the planet, being a binary planet. What is all this talking about? Binary is basic computer thinking. Binary code is a series of ons and offs, which are ones and zeros. Uh, all computer processing comes through sending a small electric pulse through a circuit. And that little pulse either happens or does not based off of a increasingly fast clock, which takes a note of when things are on and off. And it's basically light switches. Your computer, all those expensive, incredibly cool processor chips inside, all contain effectively, not physically, not literally, but effectively thousands or millions of tiny light switches that turn on and off. And all numbers and all information has been boiled down on computers to simply a series of ons and offs of switches. Even if the switches are more hypothetical switches than literal ones. So that's a binary system. That means everything is either on or off. In fact, anything called digital should be based off of binary data of ons and offs. And however detailed, how many layers of code and however many layers of binary data you layer on top of each other determines how complex a thing you can make out of the same basic ons and offs. Every picture you see on these videos, Zoom itself using to record them, as well as all the graphics in your favorite movies, games, and the graphics you create to print and help other people create. That is all binary information, and your computer is simply interpreting millions of bits of information of yes or no's. Let's talk platforms, because how these binary bits, and yes, bit is the technical term, a bit is a single piece of binary information. One bit is a single on or off. 8 of those is a byte, B-Y-T-E. And if you start breaking it down, things like kilobytes, although that's kind of out of vogue now because computers have gotten so much bigger on the inside, megabytes, gigabytes, terabytes, that's all how many thousands, millions, or billions of bytes of 8 sets of ones and zeros are. Also, I should mention before we get into this too deeply that 8 bits, and yes, this does also relate to those things like old 8-bit video game systems because that used 1 byte of data. 1 byte, those 8 on and off switches have the ability to count based off of how binary numbers work. And don't ask me exactly how that is. There are plenty of resources out there. I'm not a programmer, so I'm not quite up on this all the way as where I probably should be. So, sorry, 8 bits gives you, or yeah, 8 bits or 1 byte gives you the ability to count from 0 to 255. Those are all the numbers. And every number between 0 and 255 are the numbers that are capable of being counted with 8 bits or 1 byte, which is the same thing, of information, which is one of the reasons that 256 shows up so common in computing and in computer graphics. That is a key central number. If you ever see something and that number comes up in it, you can bet your bottom dollar the computers are involved, because that is an oddly specific number to keep randomly running into. So, platforms. How are these different ons and offs word? How are they interpreted? How are they used to translate into actual language that humans can know? That is depending on the platform you use. The 3 main platforms out there are Macintosh, Windows, and something called Unix. Unix is not the same as Linux. Actually, Mac and Windows are basically Linux now. Back when Mac switched from OS 9 to OS 10, and somewhere around the time that Windows left XP and jumped up to Windows, was it 7 right after that? Around that time, both of them decided to, we'll just say adopt the methods of the open source and therefore free Linux to create their own versions of Linux that they could sell with their name stamped on them. One of the reasons so many things are compatible now is because they both took that code and kind of made it their own. Unix is different though. Unix is more of a developer space. It's a different code that does not exist inside Windows or inside Mac. And it's a place that a lot of people use when developing software because it lets you work without accidentally triggering your own operating system. So these operating systems, some of this is going to be a little bit of your instructor's personal preferences here. A good operating system is one that helps you navigate through your files and folders and find the applications and the documents that you need and then gets out of your way. When you work with a lot of graphics, you become a bit territorial over the processing power and the amount of time it takes your computer to be able to process different images that you're working with. If you're working with a lot of image heavy catalog type stuff, like I have done in printing and graphics, or if you're doing something like video editing, you start to understand how quickly your computer's resources get used up and spent on complicated projects. It is frustrating is an understatement. It is infuriating to me to have your operating system have so many bells and whistles and fun little special features and doobobs that make it fun and cutesy and sell more copies that waste your computer's resources, which is to say they make your computer run slower so that they can animate the opening of that window a little bit better. Or they waste your computer's speed, that you could have processed that picture a few seconds or a few minutes faster, but your OS needed that power part of your computer so that it could be touchscreen, which also is a very clumsy interface. Don't start me on touchscreens. We'll be here all day. So anyways, the two main ones of Windows and Mac are commonly used. They're both equally good at this point in history. Mac used to be better. But now they're basically both Linux. They're basically both the same. They're Linux with extra things you don't want added to them. Let's talk about digital file storage. A computer needs to, or a file storage system needs to remember all of those ons and offs. Different codes of different sequences of on and off patterns through that math are used to describe text, image, page size, whole computer games, movies, whatever it is that is on your computer is defined that way. To store it, you have to have a device that's capable of remembering little ons and offs. The top middle here is called a hard drive. That's a traditional computer storage system from most of my life with computers, which has actually been most of my life, being a child of the age of the home computer. I grew up alongside Macintosh and just slightly older than Mac. Anyways, for the longest time, this is what it was. You had multiple spinning platters. That big CD-looking disc is not a CD, that's a magnetic disc And there are several of them. Bigger ones had more, smaller ones had fewer, and it spins around, physically spinning on a little motor. And you can see those triangular things that kind of look, well, if you're old enough, kind of look like a record needle. Those are the reader heads, and those actually will, as the disk spins, the reader head will see ons and offs as it goes in sequence and know what number and therefore what code it's looking at. And that's how it works. The downside of this is, one, you have to spin it, and your speed of being able to read and write data is limited by the speed of how fast your computer can spin the uh, the disks and read them through its little reader. So that's the older type. Also, that means in laptops, especially it's a bigger issue in laptops. Traditional hard drives require more power because you have to have a motor running the whole time that you are using your computer, and that motor not only makes it louder and hotter, but also uses a lot of power. So that limits you as well there. Likewise, having moving parts means if someone bumps you or jostles you, or if you are like me and are clumsy, you're going to bump things around, and bumping a spinning, moving computer part is not a good look. Anyways, so that's more traditional. Bottom left is CDs and DVDs, which do similar things optically. Actually, they work very similar to how the traditional hard drive works, except it's a laser reading optical scarring on the surface of a refractive coating, as opposed to reading magnetic signals from the OG, what do you call them, hard drives. In fact, also the hard drives being magnetic based is one of the reasons that putting a magnet up to a computer would erase a bunch of data and hurt your computer. CDs work much in the same way. They are not obsolete yet, and I like them quite a bit because they are a very secure, stable way of storing and transmitting data. Transmitting? Yes, you physically hand it to somebody. The beauty there is if you're working with information that's more sensitive, and I don't necessarily mean like secret organizations and spy documents and big stuff like that. But no, a lot of companies try to keep their information secret from each other so that their competitors don't go out there and sell the same type of thing for $1 less a day sooner. And then your big release is totally foiled. So a lot of companies value secrecy about what they're working on. Anyways, you can't hack a CD unless you have it. There's no digital record, there's no email server you can break into to get this. If you're putting information on a CD and giving it to someone, the only person who gets that information or even has access to it is someone who can physically hold that disk in their hand. And that's useful. Likewise, they're very shelf stable. Some of the other types of memories don't last very well if you try to store them. I've seen a lot of flash drives corrupt over the years, where you think you're storing information, then it's someday you just go on and the thing's blank or says cannot open. Would you like me to rewrite this? And you go, oh no, all that information, it's gone. CDs don't do that unless they're scratched to death, which does happen. They can store so far. I mean, I don't know about indefinite. They've only been around for a while, but I've seen CDs last 30 years. So that's pretty good. Anyways, CDs, not as obsolete as you think they are. Although DVDs are better because they store more information because the laser has a finer focus and other information that I don't quite understand. On the bottom right is a flash drive, or a thumb drive as they were called for a while. This is a different type of memory. I'm not totally sure how it works, but it's able to, when it's plugged in, charge the physical parts of it somehow and store a bunch of data on it, and then kind of just hold it until you plug it in somewhere else. I'm not 100% sure how they function, and there are other places to learn that. They are very commonly used now. USB is pretty standard. Thankfully, they live up to the U in Universal. Although some more recent computers have been getting cute with their reliance on the cloud and not letting you have direct places to plug them in anymore. But you can always get adapters to what holes they do give you, and you can always plug them in. They're very useful for transferring large files from one computer to another. They're very compact and they have a lot of memory. I remember my first one I bought for over $100 back in the early 2000s. And that's a lot of money in the early 2000s. And it held somewhere around 32 megabytes of data. At the time, that was a lot. They've come a long way. 64 gigabytes is something you, like on this slide, something you give away for free now. Sure, here's a take-home thing from our trade show. It's basically a business card. Just take it. It's multiple gigabytes of data. You get to store on it, have fun. Okay, we're going to stop with storage here because I'm almost out of time on this video, and we'll come back for another one. Thank you for listening.